Okay, so today we're going to talk about Section 2.8, Function Operations and Compositions. Three of the objectives we'll be talking about today include arithmetic operations on functions, the difference quotient, and composition of functions and domain. So arithmetic operations on functions. So we have a graph here. It shows R of x and C of x. The graph shows the situation for a company that manufactures DVDs. The two lines on the graph of the linear functions for revenue, R of x is 168x, and cost, C of x, is 118x plus 800, where x is the number of DVDs produced and sold, and x, R of x, and C of x are given in thousands. When 30,000 DVDs are produced and sold, profit is found by taking revenue minus the cost. So the profit of 30,000 CDs is equal to the revenue of 30,000 CDs minus the cost of 30,000 CDs, which would be 5,040 minus 4,340, which is $700. So the profit is that 700, since we're talking about in thousands of dollars, that 700 is a profit of $700,000. So operations on functions. If I have two functions, f and g, then for all values of x in which both f of x and g of x are defined, then the functions f plus g, f minus g, f times g, and f divided by g are defined as. So instead of writing f plus g, if we want to be specific, we're talking about the f function in terms of x and the g functions in terms of x. We would write that as f plus g of x. So if you see it written this way, f plus g of x, that's the same thing as find the value of f at x, find the value of g at x, get those two values and combine them. Difference would be the same. If I wrote f minus g of x, what I'm really saying is take the function f, evaluate it at x, get an answer, get the value of g at x, and then take the difference. If I say fg of x, that means take the f function at x, take the g function at x, get those two answers, multiply them together, and division is the same. F divided by g of x simply means take the f function, evaluate at x, take the g function, evaluate at x, and then find the quotient. Notice here, though, that g of x can't be 0, and that's because we can't divide by 0. So the domains of f plus g, f minus g, and fg include all real numbers that are in the intersection of both f and g, while the domain of f over g includes all real numbers, the intersection domain of f and g, except, again, g of x can't be 0, and that goes back to the fact that you can't divide by 0. So let's look at a problem here. So if f of x is equal to x squared plus 1, and g of x is equal to 3x plus 5, we have two separate functions here. So in case of letter A here, it says find f plus g of 1. So what that's saying is evaluate the f function at 1, evaluate the g function at 1, and add them together. Okay? So f plus g of 1, that simply means f of 1 plus g of 1. So that's what we're going to do. Well, f of 1, if you plug a 1 into this function here, 1 squared is 1, and 1 plus 1 is 2. And then if you plug the 1 into the g function, right here, plug a 1 into that, well, 3 times 1 is 3, and 3 plus 5 is 8. So f of 1 is 2, g of 1 is 8, and obviously if I combine those together, 2 plus 8, that's going to be 10. Part B, f minus g of negative 3. So again, that simply means take the f function evaluated at negative 3 and subtract the g function evaluated at negative 3. Now be very, very careful when you're subtracting because if you get a polynomial, if you will, in that g function, if you're evaluating, and you'll see it later on, that negative sign is going to be very, very important. So that negative sign goes to everything in the g function there. Okay, so let's evaluate f of -3. Well, that means we're going to take this f function again, and we're going to plug in -3. -3 squared. Well, -3 times -3 is 9. 9 plus 1 is 10. Minus, now let's do the g of -3. So I'm going to take this g function right here and plug in a -3. 3 times -3 is -9. -9 plus 5 is -4. And so now you can probably see how important that negative sign is there, because when I get done with this, I end up with a 10 minus -4. And of course, 10 minus -4 is the same thing as 10 plus 4. So our final answer on this one is 14. We have the same two functions here, but now let's do fg of 5. So fg of 5, that means I'm going to take f of 5 and multiply it by g evaluated at 5. So f of 5, take the f function and plug in a 5. So 5 squared is 25. 25 plus 1 is 26. And we're going to multiply that by the g function evaluated at 5. So we plug a 5 into that. 5 times 3 is 15. 15 plus 5 is 20. So we have 26 times 20. And 26 times 20 would be 520. And part D, I want to take f divided by g of 0. So that means the function f evaluated at 0 divided by the function g evaluated at 0. So plug in 0 to the f function right here. 0 squared is 0. 0 plus 1 is 1 over. Now we'll evaluate the g function at 0. Plug a 0 into this. 3 times 0 is 0. 0 plus 5 is 5. And it looks like our answer there is 1 divided by 5, 1/5. And that does not reduce, so we leave it like that. Let f of x equal 8x minus 9. G of x is equal to the square root of 2x minus 1. Find each of the following and give the domains. All right. And so the last ones, we weren't looking for the domains. We were just plugging things in. Now we're going to look at the domains. And the reason we're looking for domains here is because we're evaluating a specific value, not a specific value. The last problems we were looking for specific values, so we didn't have to worry about the domain because we knew the numbers we were using. So in this case, f plus g of x. Again, that means we're going to take the f function, evaluated x, and we're going to add to it the g function, evaluated x. Well, obviously we're not doing anything here. We're just taking the f function, which is 8x minus 9. So the f function is 8x minus 9, and then plus the g function is the square root of 2x minus 1. Now state the domain. It's saying, you know, what can x be? Well, remember when you're looking at equations or expressions, we start off by assuming that the domain is all real numbers, and then we start looking for, well, what are the exceptions? Well, in the case of this problem right here, we do have an exception with this piece. On the blue part, 8x plus 9, I can plug any x value into that. I can multiply any x value, any real number that I can think of, multiply by 8, and then subtract 9 from that answer. But when you look at the square root of 2x minus 1, we got a problem. And that's because with real numbers, you cannot take the square root of a negative number. So because that's the case here, I know that 2x minus 1 cannot be a negative number. So what I'm saying is 2x minus 1 must be greater than or equal to 0. Because if it's less than 0, it's a negative, and we can't take the square root of a negative number. So we'll solve this inequality here by adding 1 to both sides. So 2x is greater than or equal to 1. Divide both sides by 2. X has to be greater than or equal to 1 over 2, or 1/2. And so what that tells me is x can be any number as long as it's greater than or equal to 1/2, and that then becomes the domain of this problem. So there's your domain. Part B, f minus g of x. Well, this is going to be pretty much the same thing, except we're taking the f function minus the g function. So we have f of x minus g of x. And that means, again, just like the previous problem, except instead of that plus sign right there, we're going to be subtracting. So the f function is 8x minus 9 minus the g function is the square root of 2x minus 1. So that is the value of f minus g of x. And we can go through the same situation as far as talking about the domain. Remember, we start the domain, we assume all real numbers, and then we look for any problems. Well, the only problem here is you can't take the square root of a negative number. So for this problem, the domain is also the same thing as we had on the previous problem. I don't need to work that out again. So the domain is x has to be greater than or equal to 1/2, which is what we got last time. Okay. Same functions. We're now looking for f times g of x. So f g of x means f of x times g of x, which again, this is simply going to mean take the two functions and multiply them together. Well, f of x is 8x minus 9, and g of x is the square root of 2x minus 1. And as we look at that problem, there's really nothing that I can do with that. I mean, sure, if you wanted to, you could distribute the square root of 2x minus 1 and have 8x square root of 2x minus 1 minus 9 times square root of 2x minus 1, but that doesn't accomplish anything, so we can leave it like it is. And here, since the domain, again, we start off with all real numbers, and in the case of this problem, we still have, all we have is a square root that we can't be negative on the inside there, so the domain is still the same as before, and that was that 2x minus 1 has to be greater than or equal to 0, and as we solved that earlier, we know that x has to be greater than or equal to 1/2, and that is our domain again. So nothing's changed so far. Part D, we have f divided by g of x. So again, that means we're going to take the f function evaluated at x and divide that by the g function evaluated at x, which in the case of this problem simply means the f function is 8x minus 9 divided by the g function, which is the square root of 2x minus 1. And for now, we're not going to go any further than that. But if we want to talk about the domain of this one, we have two situations. Situation number one is we can't take the square root of a negative number. So we know that 2x minus 1 must be greater than or equal to 0. And we've done this several times already. So we know that that simply means that x has to be greater than or equal to 1/2. But we also have another situation here. So not only can you not take the square root of a negative number, you also cannot divide by 0. So whatever is inside here, since we're taking the square root, 2x minus 1 can't be 0, because if 2x minus 1 was 0, the square root of 0 is 0, and we can't divide by 0. And so to solve this problem, we would say, well, 2x can't be 1 by adding 1 to both sides. And then dividing both sides by 2, we say, well, x can't be 1/2. So now we have a dilemma here. In green, we said the domain is x has to be greater than or equal to 1/2. But then here in magenta, we said, well, but x can't be 1/2. So in order to satisfy the domain, both of these must be true. And so for both of those to be true, x can't be 1/2. So the final domain for this problem is x is greater than 1/2. So basically all we did for the domain is we knocked out that 1/2, because 1/2 would give us a 0. And so just a quick review on ways we could write that. All of my domains, I was saying x is greater than or equal to 1/2 on all parts except for part D here. And so let me write that using interval notation, just to touch base on that again. So in interval notation, if x is greater than or equal to 1/2, it can be anything from 1/2 up to infinity. But it can be 1/2. So because it can be 1/2, we put a bracket on it, 1/2, comma, up to infinity with a parenthesis. And remember, a bracket, if you look at a bracket closely, draw it slowly here, the top and the bottom of a bracket look like an equal sign. So maybe that'll help you remember that if you put a bracket, that means, yes, it does include, it does equal 1/2. On part D, it cannot equal 1/2. So to write the interval notation for the domain for part D, it would be parenthesis 1/2, comma, infinity, close parenthesis. And again, we always put parentheses around infinity because, you know, there's not an exact value. All right. Okay. Moving right along. If possible, use the given representations of functions f and g to evaluate f plus g of 4. Okay, so let's look at part A here. The f function is in blue, and the g function is in purple, and it wants to evaluate f plus g of 4. Well, on the blue function here, the function evaluated at 4, if I go over to 4, which is right here, and I go up, I'm right there. And so that value is 9. And for the purple one, again, if I go to 4 and go up, I'm right here. So g of 4 is 2. So f plus g of 4 would be those two numbers combined. 9 plus 2 is 11. Part B, f plus g of 4. So it's the same thing. F function evaluated at 4 is 9. The g function evaluated 4 is 2. And 9 plus 2 is 11. Part C, it's the same thing here. f of 4 would be 2 times 4, which is 8, plus 1 is 9. And g of 4, the square root of 4, g of 4, the square root of 4 is 2, and 9 plus 2 is 11. So all three of those is the same evaluation. It's the same equation. You can see the equation as a graph, as a table, or as equations. Well, what about subtraction and plugging in -2? So let's look at, and again, all three of these are exactly the same, and you can see what's going on in each of them. Here's the graph, here's the table, and here are the equations, all of the same functions. And so f minus g of -2, again, that's going to mean take f of -2 and subtract g of -2. So if we look at the graph, f evaluated at 2 is up, I'm sorry, -2. F evaluated at -2, here's -2, so down here we're at -3, minus g evaluated at -2. Well, if I go to -2, the g function doesn't exist over here. The g function started at 0, 0 there. There is no value. Okay, as you can see right here, when x is -2, g of x is undefined. You know, look at g of x. What's the square root of -2? Well, we can't take the square root of -2 in the real numbers, so that's undefined. And -3 minus, I can't do this. I can't do math with an undefined number. So the problem said if possible. So obviously this in here is not possible. Can't do that. It's not defined. If possible, find fg of 1. So fg of 1, that means we're going to take the f function evaluated at 1 and multiply it by the g function evaluated at 1. Well, the f function evaluated at 1, here in blue, here's 1. Go up, where does it cross? It's right there. Looks like 3 times the g function also evaluated at 1 is right here, it's 1, and 3 times 1 is 3. Okay. So that's talking about both of them evaluated at 1 right here, multiplying 3 times 1. 3 times 1 is 3. Or plug them in if you have the equation. 2 times 1 is 2. 2 plus 1 is 3. So this is 3. The square root of 1 is 1. 3 times 1 is 3. F divided by g of 0. That means take the f function, evaluate it at 0, and divide that by the g function, evaluated at 0. Well, the f function evaluated at 0 is right here. That's 1 divided by. The g function evaluated at 0 is right here. So the g function does exist there. It just happens to be 0. A little glitchy on the board there. Sorry about that. And we can't divide by 0. So because we can't divide by 0, this is undefined. All right, we got a little. All right. Suppose a point P lies on the graph of y equals f of x, and suppose h is a positive number. If we let x, f of x, denote the coordinates of P, and x plus h, f of x plus h, denote the coordinates of Q, then the line joining P and Q has a slope as follows. Okay, so we're getting into the difference quotient here. So the difference quotient is right there on the screen for you. This is your difference. Whoops. That is your difference quotient. Okay. So it's the value, the function evaluated at x plus h minus the function evaluated at some x value divided by h. And right here it says h can't be 0. And again, that's because it gives back to the fact that you cannot divide by 0. So here's the picture of it. Here's some kind of a graph. Here in blue, that's my function. If I evaluate the function at some point x, which is here, and then find another value, x plus some h, and we're going to use h, we're going to use a letter there. And basically what we're doing is we're finding the slope of the secant line. And recall a secant line is a line that goes through a graph touching it twice there. So if f of x is 2x squared minus 3x, find and simplify the expression for the difference quotient. So I need to find both f of x plus h and f of x. And when I'm working these, I like to work them independently. So if I wanted to find f of x plus h, I'm going to take the function right there, and anywhere I see an x, I'm going to replace that x with x plus h. So I have 2, and there's an x, so x plus h squared minus 3 times x plus h. Okay, and so to simplify this, using my order of operations, I'm going to take that x plus h and I'm going to square it first. And recall, if I have x plus h squared, that's the same thing as x plus h times x plus h. And I'm going to double distribute. X times x is x squared. X times h is xh. But then I'm going to take the h and distribute it. X times h times x is also xh. So I have x times h and h times x, which is the same thing. So I have plus 2xh and then plus h squared. I'm going to distribute this negative 3, so minus 3x minus 3h. Distribute the 2 over here, so 2x squared plus 4xh plus 2h squared minus 3x minus 3h. And now combining like terms, and I don't have any. Okay, so there is your value for f of x plus h. Okay, so now let's do f of x. Well, f of x is given, it's 2x squared minus 3h. So let's go ahead and start putting this all together here. So f of x plus h is this right here. I'm going to subtract f of x from that. Okay. Well, if I subtract f of x, then I'm going to have minus 2x squared. So minus 2x squared. And then if I subtract a negative 3x, that'd be the same thing as adding a 3x. I'm going to add a 3x over here. And if you'll notice what I'm doing here is I'm taking care of my numerator of my difference quotient right now. So this right here is my numerator. And if I simplify that, 2x squared minus 2x squared is gone. Negative 3x plus 3x is gone. So all that's left is 4xh plus 2h squared minus 3h. So that is my numerator. So now let's go ahead and put this together. This is my difference quotient. My numerator is 4xh plus 2h squared minus 3h divided by my denominator is h. If you'll notice in the top, I can actually factor out an h So factoring the numerator, I have h times 4x minus 2h minus 3. So remember, factoring is the same thing as division. Because I pulled that h out, I took each of those terms and divided it by h. 4xh divided by h, the h cancels, leaving me with the 4x. 2h squared divided by the h, one of those h's cancels, leaving me with just 2h. 3h divided by h, the h cancels, leaving me with just the 3. And this is all over h, and those h's cancel. And so all that's left here is my final answer. So my difference quotient is, I'll write it in green here, the difference quotient once you cancel those h's, all that's left is 4x minus 2h minus 3. And so that is your difference quotient. The diagram below shows a function g that assigns to each x in its domain a value g of x. Then another function f assigns to each g of x in its domain at the value f of g of x. This two-step process takes an element x and produces a corresponding element f of g of x. So again, an x value goes in. It goes into the g function. If you'll notice, f of g of x, if we simply follow, sorry about that, f of g of x, if we follow our order of operations, we're going to work inside out. So that's why the input goes into the g function, because it's on the inside. You evaluate that value of x, you get some answer. Once you have that g of x value, that plugs into the f function, and that's why you look at f of g of x, and the output is f of g of x. This is a composition of functions, f and g, which is written f of g. Okay, so look at that little circle there. Okay, that little circle there indicates we're talking about a composition. That little circle right there. Okay, it's not a multiplication dot. It's an open circle there, f of g. And you'll hear me read it as f of g. Sometimes people might say it f composed with g. You probably won't hear me say that unless I'm reading f composed g right out of the text or something like that. Typically, I'm going to read it f of g. And I tell you, anytime that I see a problem written as f of g, anytime I see it written this way, I'm going to immediately change it to f of g of x, because to me that makes more sense. I can see that we're talking about the g function evaluated of x, and then take that answer to find the f function evaluated at that g of x value. It's kind of messy here. Here it is written out. So if f and g are functions, then the composite function or composition of f and g is defined by f of g of x is the same thing as f of g of x. So it's just like when we're doing adding and subtracting and multiplying and dividing. You can write it as f of g of x in this case. The domain of f of g is a set of all numbers x in the domain of g, such that g of x is the domain of f. Here are two functions. F of x is 2x minus 1, and g of x is 4 over x minus 1. The problem says find f of g of 2. And so again, anytime I see a problem written like this, I'm going to rewrite it as f of g of 2. And now I'm just going to do order of operations. Order of operations tell me to do inside parentheses first. So the first thing I want to do is find out the value of g of 2. That means take the g function evaluated at 2. 4 divided by 2 minus 1. 2 minus 1 is 1. 4 divided by 1 is 4. So g of 2 is 4. Well, now that I know what g of 2 is, I'm going to take this g of 2, which is 4, and plug it in right there. So now I'm down to f of g of 2, but g of 2 is 4. So now I'm going to evaluate the f function at 4. That's 2 times 4 minus 1. So f of g of 2 is equal to 8 minus 1 is 7. So order is important. I know this isn't the same numbers here, but notice in part B it says g of f of negative 3. So again, I don't like writing it that way. I'm going to read it to you again. It says g of f of negative 3. Well, I could write that as g of f of negative 3. Inside out, I'm going to evaluate f of negative 3 first. So f of negative 3, take the f function, plug in the negative 3, 2 times negative 3 minus 1. 2 times negative 3 is negative 6, minus 1 is negative 7. So f of negative 3 is negative 7. So if f of negative 3 is negative 7, what is g of f of negative 3, which happens to be negative 7? So what is g evaluated at negative 7? That would be 4 over negative 7 minus 1. That would be 4 over negative 8. And of course, that's simply going to be negative 1/2. So f of g of negative 3 is negative 1/2. Given that f of x is the square root of x and g of x is 4x plus 2, find each of the following. So let's do f of g of x and its domain. Okay, so f of g of x means take the f function and anywhere you see an x, replace x with the g of function. But remember, g of x is this right here. Okay? So my f function is the square root of x. But x is going to be replaced with g of x. But g of x is 4x plus 2. So 4x plus 2. So that is the value. And because this answer here is a square root, remember you cannot take the square root of a negative number. So by looking at this, talking about the domain, 4x plus 2 cannot be negative, so it has to be greater than or equal to 0. Subtract 2 from both sides. 4x has to be greater than or equal to negative 2. Divide both sides by 4. X has to be greater than or equal to negative 2/4 or negative 1/2. So I want to point out here the fact that x can be negative. I am taking the square root. X is inside. X can be negative, okay? But 4x plus 2 cannot be negative. So that's very, very important there. So the domain is anything bigger than or equal to negative 2. And we write that in interval notation. It can equal negative 2, negative 1/2. And anything bigger than that, all the way up to infinity. Okay, and we always put parentheses around infinity. So there's your domain, from negative 1/2 to infinity. Same functions, g times f of x. So that means, not g times f of x, g of f of x. G of f of x. Meaning, take the g function, anywhere you see an x, replace the x with f of x. So, my g function is 4x plus 2. 4x. But x is going to be replaced with the square root of x. Square root of x plus 2. I took the f function, square root of x, and plugged it into the g function. For the domain on this, Remember, we always start with the domain can be anything, and then we look for the exceptions. We do have a square root here. We cannot have the square root of a negative number, so we know that x has to be greater than or equal to 0. And there's nothing to do to simplify that. It's done. And so that means x can be anything from 0 to infinity. A bracket around the 0 meaning, yes, 0 is included as a part of that domain. F of x is equal to 6 divided by x minus 3. G of x is equal to 1 over x. All right, I want f of g of x. That means take the f function, and anywhere you see an x, replace it with g of x. So I have 6 over, there's an x, but I'm going to replace that with 1 over x. And that's going to be subtracting 3 from that. Just to clean this up a little bit, instead of having a fraction inside of a fraction, if I was to multiply this by x over x, and I can do that because if you multiply something by 1, it's legal, right? And x divided by x is 1. So my numerator, 6 times x is 6x. And on the bottom, this x is going to be distributed. X times 1 over x is 1, minus x times 3 is 3x. So that is the value of f of g of x. And we need to talk about the domain. And so one thing you want to do is go to the very beginning. In this particular problem, because I'm using both f and g, I want to look at my original problem here. And remember, you can't divide by 0. So by looking at this first one, x minus 3 can't be 0, which implies x cannot be 3 by adding 3 to both sides. Looking at this other one, look at my denominator, x cannot be 0, okay? So I know for sure that those two values cause a problem. So x can be anything except for those two values. And to state that, so if you think about a number line going from negative infinity to positive infinity, it can be anything, x can be anything on that number line, but it cannot be 0 and it can't be 3. So we have to write the domain to exclude the values of 0 and 3. So think about the number line going to from negative infinity up to 0, but it can't be 0, so we would put a parenthesis there. Union, meaning, but there's more. It can also be anything from 0 to 3, and again, parentheses means not including. It can't be 0, it can't be 3. Union, but it can be bigger than 3, so it's going to start back up at 3 and go to infinity. And so this right there, this is the domain. So again, parentheses excludes, brackets means it is included, and you see parentheses around the 0 on both sides, so I've excluded 0. You got parentheses on the 3, I've excluded the 3. I also want to point out, I've said this many times, when you're doing interval notation, you always go from smallest to largest. Negative infinity is super, super small. 0 is bigger than negative infinity. 3 is bigger than 0. Infinity is bigger than 3. Always, always, always small to large. G of f of x and its domain So this means we're going to take g of f of x all right. So take the g function, anywhere there's an x, plug in f of x. So we have 1, my g of x, over x, but x is going to be 6 over x minus 3. 1 divided by 6 divided by x minus 3 is the same thing as when you divide by a fraction, the same thing as multiplying by the reciprocal. So that's the same thing as x minus 3 over 6. And if you look at that, x minus 3 over 6, you're thinking, well, x can be anything. But go back. No, it can't be, because we have an x minus 3 in the denominator here. And I'm going to go back to that previous problem and change something. So, so this can't be 0. X minus 3 can't be 0, which means x can't be 3. Okay? And that comes from the f function. You cannot plug a 0 into the f function to begin with. And so as long as I don't plug that in, then I'm not going to get an illegal value for g of x. So the domain for this guy is anything but 3. So it's going to be negative infinity to 3 union 3 to infinity. Okay, let me go back. I misspoke on part A, so I want to go ahead and fix that real quick. Let's kind of start over looking at this domain here. Okay, when we're looking at this domain for part A, let me erase this real quick. Sorry about that. Okay, we want to look at the g function because that's where we start, and we want to look at our answer. Okay, so if you look at the original problem, so this doesn't apply for this problem. If the original problem I start with a g, I see that x can't be 0. And then I look at my final answer here when I take f of g of x, and I get this 1 over x minus 3. Well, 1 over x minus 3 can't be 0. That means that 1 over x can't be 3. Multiply both sides by x. 1 can't be 3x, so x can't be 1/3. And so x can't be 1/3 and it can't be 0. So the domain for this guy is from negative infinity to 0, union 0 to 1/3, union 1/3 to infinity. So x can be 3 for this problem because we start with the g function, and x can be 3, which would give us 1/3. Plug into this function, which that is acceptable. Okay, so the only thing that has to be excluded is we started with g of x on the inside, so this can't divide by 0, so x can't be 0. And we look at our answer once we plug the g of x into f of x, and 1 over x minus 3 also cannot be 0, and that's where the 1/3 comes from. All right, sorry about misspeaking there. Okay, showing that g of f of x is not equivalent to f of g of x. So I have two functions, f of x and g of x, two different values, and I want to show that g of f of x is not the same thing as f of g of x. So let's start with g of f of x. So take the g function, and anywhere that I see an x, I'm going to replace it with f of x, so 2 x squared, but x is 4x plus 1 squared plus 5 times x, which is 4x plus 1. So following my order of operations, I'm going to square 4x plus 1. And if you need to do that separately, or if you want me to go into more detail, just contact me about where this came from. If I take 4x plus 1 squared, that means 4x plus 1 times 4x plus 1. That would be 16x squared minus plus 8x plus 1. Distributing the 5. 5 times 4x is 20x. 5 times 1 is 5. Distribute my 2. I have 32x squared plus 2 times 8x is 16x plus 2 times 1 is 2 plus 20x plus 5. Combining like terms, I have 32x squared, and then I have plus 16x and plus 20x, so plus 36x, and then I have plus 2 and plus 5, so plus 7. So g of f of x is 32x squared plus 36x plus 7. Let's flip it around and find f of g of x. Meaning, take a function 4x plus 1, and anywhere I see an x, I'm going to replace it with 2x squared plus 5. So here's an x, so 2x squared plus 5 plus 1. Clean that up, distribute the 4. I get 4 times 2x squared is 8x squared plus 4 times 5 is 20 plus 1. So 8x squared plus 21. And you'll notice that these two things right here are not equal. So f of g of x and g of f of x are in fact not the same. But what if they are? If g of f of x and equals f of g of x, then the functions are called inverse functions. This concept will be addressed in section 4.1. Finding functions that form a given composition. Okay, so what we're going to do here is I'm telling you that f of g of x is equal to x squared minus 5 cubed minus 4 times x squared minus 5 plus 3. There is not a unique answer to this question. Find two functions f and g such that f of g of x is equal to that. Several ways to do it. The most obvious way is to look for something that repeats. In this case, I can see that x squared minus 5 repeats. So that's an inside piece of that function that repeats. So I could actually say that g of x is equal to x squared minus 5. And again, I'm starting on the inside. F of g of x is the same thing as saying f of g of x. So I started from the inside. I'm going to work out from there. So that g of x, I'm saying, is x squared minus 5. Well, if we replaced x squared minus 5 with just an x, I would have x cubed minus 4x plus 3. So here's my f of x, and if I take that f of x and take the g function and plug this into my x right there, you'll see that I'll get that f of g of x that I started with. Okay, so again, there's other ways to do this, but that's the most obvious one. And so when you're working these, go with the most obvious. The computer will probably accept other ones, but let's stick with the most obvious. That way we're all speaking the same language. All right, folks, that is the end of 2-8. Contact me if you have any questions. Be happy to help you. And we'll see you on the next video.